Hi there, Year 11s. We've got a question for exercise 3J. Question 1a. We're going to be looking at finding the points of intersection of the line with the equation y equals x minus 2 and the parabola with the equation y equals x squared minus x minus 6. What we have here essentially is we've got a parabola shape, okay, and we've got a straight line x minus 2 that could go something like this. So this could be the scenario where we're trying to find the points of intersection. And so those point of intersections, one of the things you need to remember is that at the point of intersection, they both have the same x and y coordinates, meaning that if this was y1, the graph of y1, the parabola, and this is the graph of linear equation y2, then at the point of intersection, y1 will equal to y2, and at the point of intersection, x1 will equal to x2. Okay, so with that in mind, if I called this y1 and I called this y2, then I know at the point of intersections, so at the point of intersection, y1 will equal to y2. Now we already know what y1 equals to. It says y1 is equal to x squared minus x minus 6. And y2 is equal to x minus 2. Now I'm going to rearrange them to have one side equal to 0, and the reason why we do that is to make our lives easier when it comes to solving, especially with quadratics. We can use null factor law. So here I'm going to say minus x on both sides to get rid of that, and then I notice this is a minus 2, so I say plus 2 on both sides. So negative 2 plus 2 cancels out to be 0. And what you end up now is you've got x squared minus 2x, and that's what? Negative 6 plus 2 is minus 4. And then from there, now we can see, well, can I factorize this to solve? And if I can't, that's when I use quadratic formula. So here, let's test the factors of 4. We've got 1, 4, 2, and 2. And is there any way that I can rearrange them so that I can get negative 2? And I'm looking at that. I can see 1 and 4. And the coefficient of x squared is 1, so 1 and 1. I really can't see a pair right now where that's going to work. So likely you're going to have to use quadratic formula at this point, or you can complete the square and the difference of perfect squares. It's really up to you which one you feel more comfortable with. I'll do both methods actually. I'll do completing the square. So completing the square, I know this is x squared minus 2x, and we've got a minus 4, but remember, what it seems that it's half the b term. The last constant that I need is half the b term squared. So negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So this would be a perfect square. But since I don't have a plus 1, I need a minus 1 as well. And then you can see here, this right there, x squared minus 2x with that extra plus 1 is a perfect squared of x minus 1 squared. Whilst this side here, minus 1 minus 4 is minus 5. So when I try to solve it now, I can say, let's add 5 on both sides. Negative 5 plus 5 cancels out. I get x minus 1 squared is equal to 5. To get rid of the square, I'm going to square root both sides, and that cancels out. So I get x minus 1 is equal to plus or minus root 5. Remember, when you square root, there is a plus or a minus answer. And finally, I say opposite of minus 1 is add 1. So I add 1 on both sides. And negative 1 plus 1 cancels out. So x is equal to positive 1 plus or minus root 5. So that means that x can equal either 1 plus root 5 or x can equal to 1 minus root 5. Okay? So that's using completing the square method. Otherwise, what you could have done is you could have gone straight to the quadratic formula. Negative b plus minus square root b squared minus 4ac all over 2a. And we can see that our a is currently 1, our b is equal to negative 2, so I'm just going to highlight them. That's my b, that's my a, and then finally here's my c, negative 4, so c is equal to negative 4. If you plug it all in, you get what? Negative of negative 2 plus minus square root, negative 2 squared is 4, minus 4 times a times c, divided by 2a. I'm just going to make that line a bit neater. There we go. And that's equal to 2 plus or minus root of, what's that? Negative 4 times negative 4 is plus 16. So root 20 over 2 times 1, which is 2. I should have put a 1 there. There you go. And we can simplify this by simplifying the root 20, which is 4 times 5. But root of 4 is 2, so 2 root 5 all over 2. And we know that since they all have a common factor of 2, you can factorize the 2. That becomes 1 plus or minus root 5 on the numerator, and denominator is still divided by 2, and conveniently these can simplify. 2 divided by 2 is 1, so your answer is still the same. X is equal to 1 plus or minus root 5. Okay? So either way, from this step, we couldn't have factorized using cross method. We had to use either completing the square, or we can use quadratic formula. Now that we've done that, we've got x. Remember, the question was asking find the points of intersection. So if you're looking for the points of intersection, you now have x, which is 1 plus root 5. You're missing the y coordinate, right? Or it could be this one as well. You got 1 plus root 5. 1 minus root 5, and you don't know what the y coordinate is. Now, so how do you find the y coordinate? Well, remember, you now just found what the x is. They both will have the same x's, but that also means they both have the same y's. Well, where'd you get your y from? Well, the y equations is up here. We already said this is your y1, and that's your y2. Now, which one would I sub x in? Remember, I've got x is equal to 1 plus root 5, or you've got x equals to 1 minus root 5. Out of the two, I would not sub it into this one. I mean, you can, but it makes your life harder. Since y1 equals y2 at the point of intersection, it's much easier just to sub it into this one. So if I were to answer the question, if x is equal to 1 plus root 5, well then y will equal to, I'm going to sub x as 1 plus root 5, and there's that minus 2. There you go. I'm just replacing the x. I'm just replacing the x there. See that? I'm just taking this and I'm substituting it there to find out what y should equal to. And then I do the same for the next one. Oh, well, actually, you can simplify this. 1 minus 2 is negative 1, so negative 1 plus root 5. So your coordinates for this one would be when x is 1 plus root 5, then the y value is negative 1 plus root 5. Okay, and then the second one is you can sub it into this one, same thing again. You've got x. If I took this and I subbed it into x, you would get now 1 minus root 5 minus 2, and again you get the answer of negative 1 minus root 5. So that means my answer is when x is 1 minus root 5, you get negative 1 minus root 5. And that's the easiest way to do it. I mean, you could sub it in here. You could probably likely get the same answer. It's just a lot more work to get there. Okay, so those are my 2 points of intersection there in red, and I'll just copy that down just to move it down over here. I just made a mess. You get the point. Okay, you get the point. There we go.